Hello again. Greetings from my office this time. Today's lesson is on linear inequalities. The objective for this lesson is to solve linear inequalities in one variable and to graph the solution set on a number line. Now, a linear inequality you're going to find is very similar in its form to a linear equation. Okay? Now, the difference here is that rather than having an equal sign, you're going to have either a less than, a greater than, a less than or equal to, or a greater than or equal to symbol right here, where we used to have an equal to symbol. Okay. Now, unlike an equal sign, an inequality shows a relationship between two things where it could be less than, it could be greater than, it could be less than or equal to, could be greater than or equal to. So they're relative to each other in relationship to their order. Now, numbers are ordered on a number line so that any number to the right of a number is greater than the other number. Okay? The solution set of an inequality is the set that contains all of the elements that make the inequality of a true statement. Now, we're going to follow a process in graphing linear inequalities. The first thing we have to do is just start by drawing a number line. And on it, we need to make sure that we draw arrows on the left and the right to represent negative infinity and positive infinity. And then we need to add little tick marks to it for the number values on the number line. Now, here's the important part. If we have a less than or equal to symbol, we're going to use an open circle. And if we have a less than or equal to or greater than or equal to, we're going to use a closed circle. Okay? And then the last step is going to be to shade in our number line based on what the inequality tells us. So here's our first example. We have y is less than 4. Okay? Start by putting our number line out there. It's got our arrows on either end. Throw in those tick marks. Put the numbers on there. And because its y is less than 4, we know that it's going to be an open circle, which means that 4 itself is not included. And we are going to shade to the left towards negative infinity because we want all of the values where y would be less than 4. So negative 2 is less than 4, 0 is less than 4, 3 is less than 4. Okay? Now, a little trick that my students often like to use is that if you actually look at this inequality symbol, it is pointing to the left. And since it's pointing to the left, my students know to shade to the left. However, you have to be very careful about using that trick. It only works if the variable is on the left side. And that's why I always like to solve with my variables on the left side of the equation. It's all coming together now, right? All right, here's our next example. Y is greater than or equal to 4. There's our number line with arrows on both ends. There's our tick marks, our numbers. And this time, we're going to have a closed circle, which shows that 4 is actually included in our answer. And we're going to shade to positive infinity because we want everything that is greater than or equal to 4. 5 is greater than 4, 6 is greater than 4, everything to the right is greater than 4. And again, if you want to use that trick, look at where that arrow is pointing. It is pointing to the right, so we know that we're going to shade to the right. Okay. So let's try a few of these on our own. Our number lines are drawn. Okay. Pause the PowerPoint, see what you can come up with on your own. draw in the numbers, open circle, close circle, shade the direction you need to, and then check back and see if it matches with what I've got. How'd you do? Do yours look similar to mine? Your number line numbers may not be in the exact same locations as mine, but the important part is to check your open and closed circles and to make sure that your number lines are shaded in the same directions as mine. Okay. Now let's talk about actually solving linear inequalities. We're basically going to use the same procedures that we used for solving linear equations. Remember that with inverse operations, addition and subtraction undo each other, and multiplication and division undo each other, and that the property of equality still applies, where if we do one thing to one side of the equation, we have to do the same thing to the other side to maintain equality. Now, generally, like I said, we're going to solve inequalities just like we solved equations. We're going to isolate the variable using inverse operations, okay? But again, instead of having an equal sign, we're going to have a less than, a greater than, a less than or equal to, or greater than or equal to. And in the end, we're going to be able to represent our answer with a number line and have a solution set to our inequality, not just a single number that's going to work. So here's our first example. We have 4x minus 3 is greater than 5. So we would start out by simply adding 3 to both sides. That would leave us with 4x is greater than 8. And you know what? I always forget this, but the animation is already in there, so I'm going to erase what I have done so that I can just add it in there. And then we would divide both sides by 4, and that would leave us with x is greater than 2. We'd put our number line there, add our tick marks, put in our numbers, and we would put an open circle right at 2. And now, because our variable's on the left, we can use our little trick of the arrows pointing to the right, so we know we need to shade to the right. Now, it can be handy at this point to check values on the number line to make sure that you've got the correct shading and to make sure that you have the correct solution statement, okay? So, for example, you could check 4, okay? 4 is greater than 2, okay? You could also check 5, okay? 5 is greater than 2. And if you were to plug 5 back into the original equation, it would work. 5 times 4 is 20. And 20 minus 3 is still greater than 5. So when you substitute it back into the original inequality, because it is a true statement, it shows you that the solution works. Okay? If we were to plug in something to the left of where we shaded, let's say we plugged in 0, okay, it should not work because it's not shaded in. 0 is not greater than 2. So if we plug it in, 4 times 0 is 0, and 0 minus 3 is not greater than 5. Therefore, it does not work, and it is not part of our solution set, and that's why we did not shade it in. Okay. And remember here that we have an open circle at 2, which tells us that 2 does not work. If we were to plug in 2, 4 times 2 is 8, and 8 minus 3 is 5. Is 5 greater than 5? No, it's not. That's why 2 does not work. Okay, it does not fit that inequality statement. All right, let's check out this one. First thing we do to solve this one is distribute. 3 times 2, or 3 times x, and then 3 times 2. That would give us 3x plus 6 is less than or equal to 2x plus 5. Okay. Now we want to get all our variables onto one side. Again, I'm all about putting things on the left because when I have things on the left and I'm dealing with inequalities, I can use that little shortcut of which way the arrow's pointing. So I'm going to subtract 2x from both sides. That's going to leave me with 1x plus 6 is less than or equal to 5. Now, do I have to put that 1 in front of the x? No. I usually write it there just temporarily, but I don't need it there in my final answer. 1x is really just the same as x. Now, because all my variables are on the left, I need to get my constant terms to the right, so I'm going to bring the 6 over to the 5. Subtract 6 from both sides, and that leaves me with 1x is less than or equal to 1. But 1x is really just the same as x. So I've got my solution there of x is less than or equal to 1. And again, I forgot that there's animation, and I also forgot my negative there. X is less than or equal to negative 1. Okay. Now, if we graph this solution, what's going to be different? If you thought about the fact that the circle this time is going to be solid or shaded in, you're absolutely right. Because we have the less than or equal to, it has to be shaded circle this time. It also is going to be shaded to the left this time. Okay. Now, if we wanted to test to make sure that we shaded the correct place, we could test values. Okay, so we could test -3, for example, and it would work because if we plugged it back into the original equation, it would give us true values. If we plugged in 0, it would not work. Okay. All right, now let's take a look at this one. Okay, this one's already solved out for us. 4x is less than or equal to 20. To solve this, it seems pretty straightforward. We divide both sides by -4, and we would get x is less than or equal to -5. Alright, sounds easy enough. Okay. However, if I were to test a value here, let's say I picked out -5. Okay? -4 times -5 would give me 20. Is that less than or equal to 20? Yeah, it is. It's equal to 20. I'm good there. Let's say I pick out -8. -4 times -8 is 32. Is 32 less than or equal to 20? No, it's not. So what's going on here? Let's try 0. -4 times 0 is 0. Is 0 less than or equal to 20? Yeah, it is. So it seems like we have our number line shaded backwards in this one. Okay. When you multiply or divide by a negative value in inequalities, the solution set reverses. Okay. This is the big major difference in solving equations versus inequalities. So if you have to take one thing home with you from equations to inequalities, this is the one thing you need to make sure you remember from equations to inequalities. Put a little star next to this, an asterisk, whatever you need to. Okay? So what really needs to happen here is that when you divide by this -4, your inequality symbol needs to reverse or flip, we often say. So notice that this symbol went from this direction to the other direction. And that was because we divided by -4. Anytime you multiply or divide by a negative value, your sign is going to flip. If you add or subtract by a negative, it doesn't matter. But if you multiply or divide, the inequality symbol will flip. Okay? So now we have x is greater than or equal to -5. And if we were to test values again, all of the values that we test now work. Okay. So let's look at one. X, or 8 minus 4y, is greater than or equal to -12 plus 6y. Alright, I need to get all my variables onto one side, so I'm going to bring my 6y over to my -4y. I'm going to do that by subtracting 6y. Cancels out on the right. I end up with a -8 minus 10y is greater than or equal to -12. I now need to bring my 8 over to my -12. I'm going to subtract it. That gives me -10y is greater than or equal to -20. Now watch here. In this step where I divide by -10, because I am dividing by a negative, my sign right here is going to flip. It goes to a less than or equal to 2. It does not matter that the 20 was negative. It only matters that the actual number I was dividing by, that 10, was negative. It does not matter that the result comes out positive or negative. Again, it only matters that the actual number I was dividing by was a -10. That's what made that sign flip. Okay, so I get my result here as y is less than or equal to 2, which is correct, but now I need to graph it. Okay. Oops. Alright, so if I need to graph that, 0, 1, 2, 3, 4, -1, -2, -3. Alright, I had y was less than or equal to 2, open circle or closed circle. Because it was less than or equal to, I'm going to put a closed circle. I'm going to shade it in. And I am going to go to the left here. Okay. There's that F word again, fractions. Everybody's favorite, right? Alright, I've got a 5 and a 4. The least common denominator I can multiply here would be 20. So I'm going to multiply everything here by 20. Again, just because it's an equality doesn't mean that anything else has changed about it. We're going to solve it just like it were an equation. So the idea of multiplying by the least common denominator is still the same. So we're going to do 20 times x over 5 minus 20 times x over 4 is less than 20 times 1. Okay. Now I can reduce here. 5 goes into 24 times, 4 goes into 25 times, and that's going to leave me with 4x minus 5x is less than 20. Now, at this point on the left side of the equation, I actually have some pieces I can put together. 4x minus 5x can combine to give me -1x is less than 20. Now I've got to divide by a -1. And because I'm dividing by a negative, my sign's going to flip. So it's going to give me x is greater than negative 20. Remember, because the number I was dividing by was negative, that is why my sign flipped there. Okay, so let's throw negative 20, negative 19, negative 18, negative 17, negative 21 on my number line. And am I going to have an open circle or a closed circle? If you were thinking open circle, you're absolutely correct. And I am going to shade to the right this time. So remember that inequalities are very similar to equations, but instead of having an equal symbol, they're going to have a less than, a greater than, a less than or equal to, or a greater than or equal to symbol. Okay? And the solution set is not going to just be a single number anymore. It's going to be a range of numbers that we can graph on a number line. Okay? And the goal when solving an inequality is to get that entire solution set and to be able to graph it as well. When we graph the solution set on a number line, we have to make sure that we put an open circle or a closed circle and that we shade in the correct direction as well.